Hello all. In today's class, we are going to learn one more important topic of database management system, that is recoverability in database management system. Also, we will be learning the different levels of recoverability. Recoverability in database management system. It refers to the ability of system to restore its state to a point where the integrity of its data is not compromised, especially after a failure or an error. Before we discuss in detail about the recoverability in DBMS, firstly let us recall the states of the transaction. We all know that whenever a transaction is in execution, it may go through several states, like it might be an active state, or it may enter into a partially committed state, aborted state, failed state, committed state. There may exist a situation when the transaction is in any of the state, the internal failures may occur. So due to such kind of internal failures or system crashes, transactions may not successfully get executed. So in that case, it is necessary to roll back the transaction. Whenever such kind of problems exist, it is necessary for one of the component of transaction to maintain a file called log file. It is going to record every of the operation that is made by the transaction. Let us suppose there is a transaction called TI, and it is going to perform a read operation on data item A, a write operation on data item A. So whatever the operation that the transaction TI is making, all such operations are recorded in a file, and that file is named as a log file. This is the example what all things that the log file is going to record. It first attribute tells about the transaction name, clear, or ID of the transaction. And next, on which particular data item the transaction is performing the operations. Let it be A. So this is my old value and this is the new value. Log file, why is it to be maintained is whenever any kind of failures occur, it is necessary for the component of the transaction to roll back in order to know the state of the transaction. So in that case, a duplicate record is maintained. Now the database is going to search for the log file and check what is the previous value of the transaction that is updated in the log file. And that previous value is taken and it is restored back into the database. A schedule can be either recoverable or it can be unrecoverable only when the state of the transaction is stored in a log file before performing a commit. Then we can say that that particular transaction can be recoverable. Then when a transaction cannot be recoverable, once a commit operation is made by a transaction, and after that if there occurs any failure, in that case the log file will get deleted. The log file is only maintained until the transaction performs a commit. Once the transaction performs commit, the log record of that corresponding transaction will be deleted by the database. What is the importance of this recoverability? We have listed three different points here. Let us read out. The need of the recoverability arises because databases are designed to ensure after reliability and consistency. It is mainly designed in order to ensure the consistency and reliability in the database. Okay, if the system is not recoverable, the integrity of the data might be compromised. If you are unable to recover the state of the transaction, once it is failed, then in that case, what happens? The integrity is lost. Business processes can be adversely affected due to the corrupted or inconsistent data. The role of recovery management component is to restore the state of the transaction after its failure. We have different levels of recoverability. Let us check out one by one. Recoverable schedules, non-recoverable schedules, cascading rollback, cascadeless schedules. The first one we have is a recoverable schedule. When can you say that the schedule is recoverable? This is the example which we have. Here we have two transactions, namely T1 and T2. Now here you can see T2 reads a value written by T1, but T1 commits before T2. making the schedule recoverable. It is only performing the read operation on the same data item where this item is updated by T1 transaction previously. So thereby what happens? There is no problem at all. Example of a non-recoverable schedule. Here again we have two transactions T1 and T2. Right of A is made by T1 and whichever updated value is made on account A, that is being read by transaction T2, and it is going to perform a write operation on another account, that is B, and T2 transaction performs a commit. Clear? Now what happens? Is this state unrecoverable or not? Let us see. It is not only enough if you roll back the operations made by T1 transaction. In this case, it is necessary to roll back the operations made by the T2 transaction as well, because you can see that whichever value that the T2 transaction has read, that is the updated value where T1 transaction made on the same data item, that is on A. But it has read the value before T1 commits it. It is also necessary to roll back the T2 operations. So making this schedule what? Unrecoverable. Next, let us see what is a cascading rollback. Here you can see we have two different transactions, T1 and T2. At some time interval, it has got aborted due to some failure. Let us assume that. Then what happens? It is necessary to roll back the T1 transaction. So if T1 transaction is to be rolled back, in this case, T2 transaction is also to be rolled back. It is because the value of A is read by T2 transaction, which is written by T1 transaction before performing a commit operation. All the transactions corresponding to the values which it has been read from the previous or the first transaction must also be rolled back, and so it is known as cascading rollback. Here you can see T2 reads an uncommitted value of A. Yes, it has read a value of A, but the value of A is not committed by T1. When T1 fails, it is rolled back, and T2 also has to be rolled back, leading to a cascading rollback. This is undesirable because it wastes computational effort and can complicate the recovery procedures. Here in the example, we have only two transactions. Likewise, if we have some thousands of transactions which are dependent on the transaction one, and all the transactions are reading the value which is updated by T1 transaction before commit, in that case, all the 999 transactions has to be rolled back. So this is a very big problem which wastes a computational effort, and it also creates a complications in recovery procedures. Next, we'll see what is cascadeless schedule. Here also we have two transactions, T1 and T2. Cascadeless schedule is one of the solution for the cascading rollbacks, which we have seen in the previous slide. So here also we have two transactions, T1 and T2. Write operation is made on data item A by T1 transaction, and then it has got committed. Right. After that only T2 transaction has started and it performs read and write operations. Read operation is made on data item A, which is already committed by T1 transaction, and it performs a write operation on B. So here B is an another account and the operation is made by the some other transaction, say T2, and then T2 finished the execution of B account. Then it leads to a commit state. In this schedule, T2 reads the value of A only after T1 has committed. So thereby, when T1 transaction fails, it does not affect the T2 transaction. After committing, if for any causes the transaction T1 has failed, then what happens? As T1 has committed the value of A, it is not required for the T2 to roll back all its operations, because T2 is reading the value of A only after the commit is made by the T1 transaction. So it is not necessary for T2 to roll back its operation. So in cascading rollback, we have seen that one of the operation, if it is rolled back in one particular transaction, all the dependent transactions must also be rolled back because the transaction has not made a commit operation. Here, as T1 made a commit operation, the values or the operations for T2 need not be rolled back. So this is not a risk of cascading rollback in this schedule. Thank you.